Welcome to Easy BTech, your guide for BTech and beyond. In this video, we will learn about how to evaluate performance of long transmission line by calculating ABCD parameters. After that, we will calculate regulation of the transmission line and efficiency of the transmission line. First, we will see the problem. A three-phase 50H long line has three conductors, each of 0.6 centimeter radius. Okay. Spaced at corners of an equilateral triangle. Equilateral triangle of size 3 meters. The resistance of each conductor. Resistance of each conductor is 0.2 ohm per phase. 0.2 ohm per phase. Now, the length of the transmission line, the length of the transmission line is 180 kilometers, and it delivers 20 MVA at 110 kV, 0.9 power factor lagging. We have to calculate ABCD constants. Find ABCD constants, sending end voltage, sending end current, efficiency of the transmission line, and percentage regulation of this long transmission line. Okay, first we will see what is the data they given. The given resistance per phase is 0.6. The given resistance per phase is 0.2 ohm per phase. Therefore, the resistance for 180 kilometers, it is per phase per kilometer, it is. Therefore, 0.2 into 180 can get a resistance equals to 36 ohm. The given radius of the conductor is 0.6 centimeters, and it is placed at the equilateral triangle. The equilateral triangle is, this is the equilateral triangle. The equilateral triangle, the distance between any two conductors is same. This is first conductor, second conductor, and the third conductor. Therefore, the D is 3 meters or 300 centimeters. The given frequency is 50 hertz, and apparent power at the receiving end is 20 MVA or 20 into 10 power 6 VA. The receiving end voltage VR equals to 110 kV or 110 into 10 power 3 volts. Okay. Now, the cos pi r is 0.9 lagging. The given lagging power factor. Now, the real power at the receiving end is S into cos pi r. S is 20 into 10 power 6 into 0.9. you can get 18 megawatt or 18 into 10 power 6 watt. Now I have to calculate inductance per phase for 180 kilometers. It is 2 into 10 power minus 7 ln d by r dash into 180 kilometers. That's why the formula up to this formula is Henry per meter. Multiply with 180 into 10 power 3, you can get for 180 kilometers. Okay, now r dash is, we know the effective radius 0.7788 into r, therefore it is 0.7788 into 0.6. Therefore the inductance for 180 kilometers is 2 into 10 power minus 7 ln d is 300 and effective radius is 0.7788 into 0.6 into 180 into 10 power 3. You can get inductance is 0.2327 Henry. Therefore XL equals to 2 pi FL. Therefore 2 into 5 into 50 into 0.2327, can get the XL value is 73.71 ohm. Okay, therefore the impedance Z equals to, we know that R plus JXL. The R value is 36 plus J 73.71. In polar form it is 81.48 at an angle 63.78 ohm. The capacitance formula, you know that capacitance is 10 power minus 9 divided by 18 ln d by r for capacitance. Okay, therefore C equals to 10 power minus 9 divided by 18 ln, d is 300 and r is 0.6. For 180 kilometers, it is 180 into 10 power 3. It is farad per meter. It is a kilometer in meter. Can get C equals to 1.609 microfarad. Therefore the admittance y equals to omega c, that is 2 pi f into 6, 2 pi into 50 into 1.609 into 10 power minus 6. Get admittance is 5.055 into 10 power minus 4 mho. Okay, now I calculated the impedance and the admittance. It is in polar form, this value is equals to 5.055 into 10 power minus 4 at an angle 90. Okay, now it is J can write 1 at an angle 90. Now the current at the receiving end, IR equals to MVA divided by root 3 into VL. MVA is 20 into 10 power 6 divided by root 3 into 110 into 10 power 3. Can get current equals to 105 amperes. Okay. Now the current vector I can represent with IR vector equals to IR at an angle minus IR. This phi r is cos inverse of 0.9. The here power factor is 0.9. Therefore the current equals to 105 at an angle minus 25.84 amperes. VR per phase, the given 3-phase voltage VL divided by root 3, it is 110 into 10 power 3 divided by root 3, we get 3508.5 volts. Okay. Now, calculating VR and IR, we have to calculate, we know that the Vs equals to, if you want to calculate Vs, AVR plus BIR. and IS equals to CVR plus DIR. We know the values of VR and IR, but we don't know A, B, C, D parameters. Therefore, first we have to calculate A. We know that A equals to, what is the formula for A? Cos H root YZ for long transmission line. This one is equals to 1 plus YZ by 2 plus Y square Z square by 24. Okay, therefore 1 plus Y, we know that 5.055 at an angle 90 into Z value. Z value is 81.48 at an angle 63.78 divided by 2 plus 5.055 at an angle 90 square, 81.48 at an angle 63.78 whole square divided by 24. Therefore, this value is 1 plus 0. Here into 10 power minus 4. So 10 power minus 4 y. 0.0270 at an angle 153.78. Right. That is 5.055 into 10 power minus 4 at an angle 90. 0.55 into 10 power minus 4 the whole square divided by 24. Now this value equals to 1 plus 0.0207 at an angle 153.78. Here at an angle theta 1 into at an angle theta 2, it becomes theta 1 plus theta 2. 90 plus 63.78, it becomes 153.78 plus this multiplication 7.06 into 10 power minus 5 at an angle theta square becomes 2 theta. Here also theta square becomes 2 theta. 2 theta into 2 theta. Okay, this is again theta 1 into theta 2, it becomes theta 1 plus theta 2. Therefore, finally 90 into 2 plus 3.78 into 2, we can get 307.56. Okay, finally after it is in polar form, it is 0.9815 at an angle 0.53. This is A. A equals to D also. A equals to D, both the cases we get the same formula. Now B equals to what is the formula for B? B equals to root Z by Y into sin H root YZ. The Z by Y, we know the Z value 81.48 at an angle 63.78 divided by 5.055 into 10 power minus 4 at an angle 90 into root YZ plus YZ in power 3 by 2 divided by 6. I have to substitute all the values here. 81.48 at an angle 63.78 divided by 5 into 0.55 into 10 power minus 4 at an angle 90 under root into root of 5 into 0.55 into 10 power minus 4 at an angle 90 into 81.48 at an angle 63.78 plus 5.055 into 10 power minus 4 at an angle 90 into 81.48 at an angle 3.78 power over 3 by 2 divided by 6. After multiplication, all the terms you get b equals to 81.0245 at an angle 63.95. Okay, this is b. Now c equals to root of y by z into sin h root yz. Y equals to 5.055 into 10 power minus 4 at an angle 90 divided by z equals to 81.48 at an angle 63.78 into root of 5.055 into 10 power minus 4 at an angle 90 into 81.48 at an angle 63.78 plus 5.055 into 10 power minus 4 at an angle 90 into 81.48 at an angle 63.78 power 3 by 2 whole power divided by 6. Okay, you get c equals to 5.0267 into 10 power minus 4 at an angle 90.17. Okay, this is the way we will calculate ABCD parameters. Now Vs equals to A VR plus B IR. Here A equals to 0.9816 at an angle 0.525 into 63508.5 plus B equals to 81.025 at an angle 63.95 into 105 at an angle minus 25.84. Here Vs value is 69213.26 at an angle 4.78 volts. Okay, this is the way we will calculate the sending end voltage. Now sending end current Is equals to CVR plus CIR. Substitute the values of C. Substitute the value of C. We get C equals to 5.0267 into 10 power minus 4 at an angle 90.17 into 63508.5 plus D equals to 0.9816 at an angle 0.525 into 105 at an angle minus 24.84. Can get Is value. Here we get the sending end current. The sending end current equals to, we know the formula, CVR plus PIR. Now the value of Is is 93. For calculating this, we get 93.897 an angle minus 7.59 amperes. Therefore, the cos pi s equals to, the sending end power factor cos pi s equals to cos of 4.78 plus 7.59. You get the sending end power factor. Now the first we have to calculate regulation. The regulation equals to Vs by A minus Vr by Vr into 100. The Vs value is 69213.26 divided by magnitude of A is 0.9816 minus 63508.5 divided by 63508.5 into 100. Get the percentage regulation. The percentage regulation equals to 11.02%. Now the efficiency equals to output by input. Output is 18 megawatt divided by root 3 VSL IS cos phi s. Substitute here, we can multiply this one. Yes. Root 3 into root 3 V phase IS cos phi s. Here 3 VS IS cos phi s. Multiply this value, substitute VS IS cos phi s, here you get 19.044 megawatt. Therefore the efficiency is 18 divided by 19.044, both are in megawatt, into 100, you can get the efficiency is 94.52%. This is the way we will calculate the performance of long transmission line. By calculating ABCD parameters, it is very easy to calculate the regulation or efficiency of the long transmission. Thank you for watching.